Physics, monthly review and exam review for semester 2. DC voltage. It is a constant electric voltage that sends a constant electric current. DC voltage, its symbol is multimeter. Multimeter is an instrument used to measure the voltage, the current, etc. To measure the voltage, we use it as a voltmeter. To measure the current, we use it as a meter. Voltmeter connected in parallel, while ammeter connected in series. The voltage across connecting wire is 0. The voltage across closed switch is 0, since closed switch acts as a connecting wire. The voltage across open switch is equal to the voltage across a dry cell. Voltage can be measured by a voltmeter and by oscilloscope. Its unit is volt. To find the voltage from oscilloscope, we use U equal SV times Y. Measuring voltage by an oscilloscope. A DC voltage appears as a positive straight line above zero line on the screen of an oscilloscope if connected correct, and appears as a negative straight line if the poles are reversed. When the voltage is positive, we notice that the line is up. When the voltage is negative, we notice that the line is down. Positive voltage and negative voltage. Kind of electric circuit in series. Voltage across the dry cell is equal to the voltage across U1 plus voltage across U2, while the current is the same. I equal I1 equal I2 equal I3, etc. In a parallel, voltage across dry cell equal voltage across 1 equal voltage across 2, while the current of the dry cell decomposed into I1 and I2. So I equal I1 plus I2. Now, alternating voltage. Definition. An AC alternating voltage is a variable and it is alternating between positive and negative values. Its symbol is alternating. Shapes of the alternating voltage. Alternating sinusoidal, triangular voltage, square voltage, and bicycle voltage. To find the voltage using oscilloscope, we use Umax equal SV times Y. Umax, it is a maximum voltage, its unit is volt. SV, vertical sensitivity, its unit volt per division. Y, number of vertical division, its unit is division. While U effective, Umax over radical 2. U effective, it is effective voltage, its unit is volt. Period. It is the time interval by which a voltage repeats itself once. To find the period using the oscilloscope, T equal VB times X. T is period, its unit is second. VB time base, it's a second per division. X number of horizontal division in division. X on oscilloscope, X from maximum to maximum, or minimum to minimum, or makes a complete cycle. So it is X. F equal 1 over T. T is a period, where F is a frequency. Its unit is Hertz. Note that the oscilloscope measures the maximum voltage, U max, while the voltmeter measures effective voltage. The voltage of ADL or generator is alternating sinusoidal. Now, the voltage of the main. Introduction. Voltage of the main is found between live and neutral, or live and ground. Electric terminals. A wall outlet in Lebanon has two outlets. Live positive terminal glow by tester. Neutral negative terminal. And ground. It is neutral terminal connected to Earth in Europe. Live main indicator tester. It is a neon lamp that glows under a voltage greater than 80 volt. When it is in a positive outlet and our finger on the other hand. Contact with live, the lamp glow. Contact with the neutral, lamp does not glow. Measuring voltage of the main. The voltage between live and the ground approximately 230 volt. The voltage between live and neutral approximately 230, while the voltage between neutral and ground 0 volt. Connecting electric appliances. Electric appliances are connected in parallel because all the devices will receive the same voltage. Now, safety elements. Fuse. It protects electric devices against a short circuit and excessive currents. Circuit breaker prevents damage and protects installation and to avoid fire against overload current. Electrocution. When you touch the live and neutral of the main will electrocuted and death result. 25 volt in damp places and 50 volt in the dry places with current more than 100 milliampere can cause electrocution. Differential circuit breaker prevents electrocution of person by metallic bodies in contact with live cuts of the circuit. Now exam review. First exercise. The document below represents a converging lens L, optical axis, object AB, and screen E. Scale 1/2. Construction. The image A prime P prime of AB by given L. Image A prime P prime formed on the screen. Redraw. Second, specify with justification position of A prime of A. A situated at the optical axis, so its image A prime is situated on the optical axis. Since A prime collinear. In addition, A prime situated on the screen, so A prime is the intersection of E and optical axis A prime. Trace with necessary explanation path of array which allow to determine B prime join BO to intersect the screen at B prime. The ray should from B passes through point O without deviation. The intersection of this ray with the screen E is B prime. B. Characteristic of the image A prime B prime. Give the nature of A prime B prime and find its size. A prime B prime real image. A prime, its size is 1.5 multiplied by the scale 3 centimeter. Number 2. Is the image A prime B prime erect or inverted with respect to AB? A prime B prime is an inverted image. 3. Find the distance D, which is OA prime between lens and image, which is 6 multiplied by scale equal 12 centimeter. Determination of focal length L. Trace with justification the path of a luminous ray which allow determination the position of image focus F prime. Draw a ray parallel to the optical axis. Immerse the lens toward B prime. The intersection of this ray with optical axis is F prime. The ray, draw ray should from be parallel to optical axis emerges and passes through B prime and F prime. The intersection of emergent ray with optical axis represents F prime. Number 2, deduce the focal length. Focal length is equal to OF prime, and OF prime is equal to 2.3 approximately times scale, which is 4.6 centimeter. Second exercise. The electric appliances in a house are fed by voltage U of the main. The adjacent figure shows the waveform of U. Study the voltage U. Part A. Name the type of the voltage. Alternating, sinusoidal voltage. B. Determine U max. U max equal as V times Y, which is SV 100 volt per division times Y, it is 1, 2, 3, 3.2. 3.2 division, which is 320 volt. U effective, U max over radical 2. So 320 over radical 2 equal 226.148 volt. C. Period T equal VB times X equal VB 2 millisecond per division. X from maximum to maximum, there is no maximum, complete cycle. So it is from here to here, all X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10 division equal 20 millisecond is equal 20 times 10 power minus 3 seconds. Frequency F equal 1 over T equal 1 over 20 times 10 power minus 3, so it's equal to 50 Hertz. D. We stop sweeping. Indicate the form of the oscilloscope of this voltage. What would be displayed on the screen? We observe a luminous segment along vertical axis on the screen from minus 3.2 division to 3.2 division. E. Determine the maximum vertical displacement. Maximum vertical displacement, it is Y maximum of the luminous spot when the vertical sensitivity is 100, when SV 150 volt per division. Find Y maximum. So Y maximum equal U max over SV, S prime V, equal 320 over 150, so it's equal 2.13 division. Role of fuse. In order to show evidence of the role of fuse, we construct the circuit of the adjacent figure. This circuit includes in series generator of voltage 220, two identical lamps L1 L2 carrying indication 110 volt 0.6 ampere, fuse F indication 0.65 ampere. First question, give the significance of each of the indication carried by the lamp. 12 volt, it is rated voltage to function normally. Rated voltage of each lamp to function normally. 0.6 ampere rated power, rated current of each lamp when it functions normally. Number 2, the voltage across F is 0. Why? Voltage across F, U across F equals 0 volt, since it acts as a connecting wire. B, determine the value of the voltage U1, U2 across the terminals L1 and L2 respectively. First, U across G equal U across F, U across L1 and U across L2. Law of addition voltage, law of addition of voltage in series connection. U across F is equal to 0. U across L1 equal U across L2, since identical lamp. Then we can say that U across L1 equal U across L2 equal U across G over 2 equal to 120 over 2 equal 110 volts. C, describe the brightness of L1 and L2, justify. U across L1 equal U across L2 equal 110 volt equal to the rated voltage, so the lamps L1 and L2 function normally. D, what is the value of the current I through the circuit? I of the circuit equal I across L1 equal I across L2 equal 0.6 ampere connected in series. Does the fuse melt in this case? Why? No, the fuse does not melt, since the current in the circuit did not exceed the market current on the fuse. 3. The lamp L2 is short circuit. How do we short circuit L2? By connecting its terminals to a connecting wire. B. Determine the voltage U prime 2 across lamp 2. U prime 2 is equal to 0 volt since it is the voltage across connecting wire, since it is short circuit. C. Deduce the voltage U prime 1 across lamp 1. U across generator equal U across F, U across 2, U across 1. U across generator 220, U across fuse 0, voltage across short circuit 0, voltage across 1, so U prime 1 equal 220 volt. Use addition of law of series connection. D. Explain why L1 burns out in this case. L1 may burn out since voltage across 1 is equal to 120 volt, which is greater than rated voltage, which is 110 volt. D. In fact, L1 does not burn out, but it will be off. Explain. L1 does not burn, but it will turn off, since the current in the circuit will increase when the voltage increase. So the fuse melt and cut off the current. F. Deduce the role of fuse. Role of fuse: to protect the lamp from being damaged when the voltage exceeds their rated voltage.